Few of the copies I have already checked for your quiz. Few of the marks also I have uploaded. The few remainings I will upload it by tonight. Okay. So by tonight you will be able to see all the marks. For some of the students I have already uploaded. Okay, so let me start with today's lecture. So I guess in the previous class we had covered up like 3 types of distillation that generally in petroleum refinery for testing your crude oil. So we actually conduct. One is this TBP test, the other one is ASTM D86, the third one is equilibrium flash vaporization. So how it is different from each other, that those aspects I have already talked about in, and which type of this type of distillation techniques actually resembles the actual distillation process that is available. So that part have already been discussed. Now whenever we deal with let's say any crude oil product, since the crude oil is a mixture of a lot of hydrocarbons, and since it's a mixture of a different types of hydrocarbon because of their carbon numbers, molecular weight also, it has a different density, different viscosity. And to negate this, or let's say to to characterize your crude oil based on its property, as well as to let's say for example, if you have a crude oil fraction which has a initial boiling point of let's say 200 degrees centigrade and a final boiling point of let's say 260 degrees centigrade. Now obviously your initial boiling point varies between in this range, but your particular fraction must also have some average boiling points. Now how do these average boiling points are being calculated and all? So among them, like volume average boiling point based on the volume percentage distilled, there is weight average boiling point based on the weight percentage of a distilled that you are being able to collect. So there are different types of average boiling point are there. So we'll try to see how, using what formulas we actually calculate those boiling point. On this type of average boiling point, today I could not actually get some mathematical problems on this, so I'll try to search it in some other books, because on the basis of this TBP data, how you can convert this data, how you can calculate hello, just a minute, wait for a moment. Hello, yeah, who's this? Yeah, who's this? Yeah, yeah, so yeah, what I was talking about, that for example, your petroleum fraction has an initial boiling point of 220 degrees centigrade and a final boiling point of let's say 300 degree centigrade. So obviously your boiling point varies between in that range, but how can I quantify, let's say that if I take like a petroleum fraction in that range, what it should be my average boiling point. So average boiling point can be like measured in by means of volume average boiling point, weight average boiling point, cubic average boiling point, and mean average boiling point. So like how, like which formula is used, how we can calculate this. So today I'm going to discuss, I guess if I'm able to collect some math problems on this TBP curve data as well as on this average boiling points, I'll try to like give you some problems tomorrow, or else like in the next week I'll definitely complete like at least have one or two problems on this, so that you can use the TBP curve data to calculate all of this value, either volume average boiling point or this weight average boiling point. So those conversion from one average boiling point to other average boiling point, how you can convert your data, those information I am also going to share. So here actually in terms of, okay, so average boiling point, obviously you pretty much understand since it has a variable boiling point range from certain boiling point to certain boiling point. So that's why we need to categorize your this particular crude oil fraction based on a single boiling point, so that it is easier for us to represent the data also. And for example, boiling, for example, if I want to calculate or measure or define my liquid viscosity and specific gravity, so what type of boiling point data we should actually calculate? We have to calculate this volume average boiling point. You can see this TBP data for 10% volume percent distilled, what is the temperature, then plus at 20% distilled, what is going to be the boiling point, like that up to 90 percentage, all the temperature data. If the TBP data is available to us, then you just divide it by 9, you will get your volume average boiling point. But the data has to be in volume percentage distilled, then only you should be able to calculate it. If like that much detailed data is also not available, but if you have like data for 20%, like boiling point for 20% volume fraction, boiling point for 50% volume fraction, boiling point for 80% volume fraction, then also it is fine. So there is another option, but you can see the similarity between here and here is that all of this boiling point data is actually at a equal interval. So this is T30 at 30 volume percent distilled, this is at T50 at 50 volume percent distilled, and this is at T70 at 70%, then divided by 3. So like average volume average boiling point is based upon the boiling point of different cuts of the fraction, usually chosen at equal interval. Here you see it is at a interval of 10, here it is interval of around 20. So like if the boiling point range, like for example your initial boiling point and final boiling point range is not that much large, then you can directly go and select your this volume average boiling point at 50%. So like 50% data would be accepted. So if the boiling point, like the fraction is boiling is over a narrow temperature range, then T50 may be accepted as the average boiling point. T50 means temperature required to indicate 50% of the stock is collected during distillation. So like 50% has been distilled. So that is how you represent this data. Similarly, based upon weight, we do the similar type of measurement, and this type of weight average boiling point, if I want to measure the critical temperature of my crude oil products, then I am going to be concerned with weight average boiling point. Similarly, molar average boiling point, this is based on the boiling point at different mole fractions. So x1, x2, x3 is the mole fraction, T1, T2 is the corresponding boiling points, and this molar average boiling point. So T multiplied by like x multiplied by T. So T1 x1 plus T2 x2 plus T3 x3 divided by the total total mole fraction, then you will get your molar average boiling point. So this type of average boiling point is generally calculated whenever we are concerned with this characterization factor, or it's okay, yeah, characterization factor or thermal expansion coefficient of your particular fraction. So then you have to calculate that, and there is another one, that is cubic average boiling point. So this is actually carried out during measurement of your viscosity. And similar to this, another things are there, that is TBP slope, and how from one volume average boiling point to other conversion, how it can be done. So those things also you can have a look into it, but for that purpose I would rather suggest, like you see, weight average boiling point, molar average boiling point, this cubic boiling point and mean boiling point, how you can convert. Like if you know this particular this volume average boiling point, you can easily check this delta T value, and you can convert it into individual individual type of average boiling point. But for that purpose, it is better that I display this with some mathematical problems, or else like the concept is going to be better, and it will be more clear to you. So that's why I'm not going to go deep details in here. So in the next week or by next class, I'll try to do some math problems on this particular average boiling point, as well as how we can use TBP data to calculate let's say characterization factor, TBP slope, or volume average boiling point. So those things we will do it in the next class or next to next class. So okay, since we have already covered this part, although we have covered it through our video lecture, so because we showed you some of the videos, like how feed condition as well as your reflux condition can adversely affect your distillation column performance or operation. So we will discuss it further, since you are asking like, what sir, tell me like where can I find what is this foaming thing, what is this entrainment, what is weeping, what is dumping, or what is flooding. So all of these things has been depicted here with proper pictorial diagram, so that the concept is pretty much clear to you. You can pretty much visualize it also. So with this, let me just start on this. So factors that affects the distillation column operation. The first point is the feed condition. So the state of the feed mixture and the feed composition affects the operating lines. Hence, the number of stages required for separation. It is also affects the location of the feed tray during the operation. If the deviation in the design specification is excessive, the column may no longer be able to handle the separation task. To overcome the problem associated with the feed, some columns are designed to have multiple feed points when feed is expected to contain varying amount of components. For example, they are saying that if the feed composition or the feed mixture has a variable composition, it can have a significant impact on the distillation column performance. Other than that, I have already told you, if some amount of water is also present in your like in addition to your crude oil, so that can also have an adverse effect. So like feed condition, feed flow rate also plays a significant role. If you increase too much of a feed rate, so what will happen? There is going to be significant amount of what should I call it, the crude oil build up on the different trays, and then flooding can take place. So other than that, reflux condition, as the reflux ratio is increased, the gradient of the operation line and the rectification section moves towards the maximum value of 1. Physically, what it means that more liquid that is rich and in the volatile components are being recycled back to the column. Separation then becomes better, thus less trays are needed to achieve the same degree of separation. So I had told you, like if I increase the let's say reflux ratio, like reflux rate or reflux ratio, not rate, reflux ratio to significantly high temperature, this like flooding can take place. But reflux ratio increasing also have a certain beneficial effects, because what we are refluxing the lighter component. So if the lighter percentage in the products is going to be like a more amount of lighter products is going to be available, so that means like separation is going to be a little bit better between like heavier products and the lighter products, so that actually can be considered as one of the advantages. And because of, if you increase your reflux ratio also, what happens, your number of stages that you may require to like fractionate a particular petroleum fraction, maybe like the number of stages requirement will go down. But obviously if you increase it too high, that may also lead to adverse conditions like flooding. So you can see this is one of the example. You see that this is through this perforated tray, how this vapor is actually rising to this distillation column, and these bubbles are actually forming and it is passing through it. So if the vapor is like too much of vapor is coming, so like that is how your flooding, entrainment, those things can take place. But this is how the vapor flows through your distillation column, and this, the left hand side, is actually called as the downcomer section, where yeah, the top product, like top liquid actually comes down, like top tray liquid actually trickles down to the bottom tray. Okay, so other effect is the foaming. So foaming is actually the starting of this higher vapor flow condition. So foaming refers to the expansion of liquid due to passage of vapor. Although it provides higher interfacial vapor liquid contact, excessive foaming often leads to liquid buildup on the trays, because if too much amount of vapor like foam is happening, so that means like too much amount of liquid is going to get retained on this particular tray, so that is what also you do not require. So in that regard it is actually negative. In some cases foaming may also be so bad that foam mixes with the liquid on the tray above. Whether the foaming will occur primarily depends on the properties of the mixture, but sometimes due to tray design condition, whatever may cause, the separation efficiency is always reduced. Because if too excessive foaming take place. Now what is entrainment? Entrainment refers to the liquid carried by vapor up to the tray above and is caused by higher vapor flow rates. So like it is like the second, like the first, when your vapor flow becomes like severely high, what happens? Foaming starts to happen. Then when you further increase the vapor flow, what happens? Your liquid starts to get carried over by your vapor to the tray above. This caused by higher vapor flow rates, which is detrimental because it reduces tray efficiency. More volatile materials is carried to a plate holding liquid less volatile liquid, because at the bottom tray obviously you are going to have less volatile liquid, and the density is going to like lower tray density is going to be a little bit higher compared to the higher tray density. So that means like lower tray will have lower volatile component, the upper tray is going to have higher volatile component. So lower volatile materials gets carried over to a plate holding higher volatile material. It could also contaminate the purity of the distillate. Excessive entrainment can lead to flooding. Now what is flooding? Okay, so this is how a foaming actually looks like inside a distillation column, and this is one example of your entrainment. Like if the vapor flow goes too down, it can also lead to whipping. So what is the definition of this flooding? Flooding is brought about by excessive vapor flow causing the liquid to be entrained in the vapor up the column. The increased pressure from excessive vapor also backs up the liquid in the downcomer, causing an increase in liquid holdup on the plate above. Depending on the degree of flooding, the maximum capacity of column may be severely reduced. The flooding is detected by a sharp increase in column differential pressure, significant decrease in separation efficiency. Now whenever you are operating a distillation column, so like obviously temperature sensor, pressure sensor, as well as like what is the separation efficiency, so that compositional analysis also you can do. So like just by looking into the pressure changes, if the differential pressure increases rapidly, so that is one of the indication that flooding might have happened. So accordingly, you have to make some calls so that the situation can be put under control. The opposite to this flooding phenomena, we have this weeping phenomena. This phenomena is caused by the opposite. When the lower vapor flow is happening, the pressure is exerted by the vapor in insufficiently to hold up the liquid, since the trays are pretty much perforated. So if you are not supplying enough amount of vapor from the bottom, so what happens, your tray will no longer be able to hold on to the liquid, and through those perforated holes your liquid is going to drip down. So therefore the liquid starts to leak through the perforation. Excessive weeping may lead to dumping, and okay, this is the liquid on like in case of dumping, what happens, this is when the liquid of all trays will crash through the crash to the base of the column via a domino effect, and the column will have to be restarted. So weeping is indicated by a sharp drop in the sharp drop in the column and reduce separation efficiency. So like for weeping also, you can actually you will find that there is certain pressure drop you might feel, and for flooding, like in case of flooding, there is going to be certain increase in the pressure. So like just by looking into your like pressure sensing device, the data whatever that is being logged there, so just by looking into those data, you can actually predict from the refinery control room itself whether your system, like your distillation column, is suffering from weeping or flooding. So this is how your VPM actually looks like through this perforated. If the vapor flow is like a vapor, like low vapor flow condition, if normal vapor flow condition, your liquid should be able to, your tray should be able to hold on to the liquid. So this is one of the examples of your weeping. So weeping phenomena has been depicted using this schematic diagram. Okay, so this part is actually done, how like your adverse vapor flow, like lower vapor flow, higher vapor flow can affect your like distillation column performance. Other than that, reboiler temperature. So like as a reboiler slowly plugs on the tube side, the bottom temperature goes down, like because if your system is having too much of suspended solid, obviously your heat transfer efficiency of your reboiler with gradual deposition or gradual fouling is going to go down. So as a reboiler slowly plugs on the tube side, the bottom temperature goes down. This leads to low vapor flow. Online monitoring of heat transfer coefficient in a control system can identify this problem early on, along with monitoring the bottom temperature. And a self cleaning heat exchanger, when used in place of reboiler, can mitigate this problem. So they are suggesting, in case of using normal reboiler, you have to use some self cleaning heat exchanger which can clean itself. So if because of the fouling, what happens, your heat transfer resistance actually gets created inside your heat exchanger equipment, and because of that there is going to be certain decrease in the bottom temperature. And if the temperature of your reboiler goes down significantly low, what happens, the vapor flow condition actually goes down. Your vapor flow within the system actually goes down, and if the vapor flow goes down, then weeping, dumping, those phenomena can take place. And reduction in vacuum, but this is going to be applicable only for vacuum distillation. So slight drop in vacuum can cause boiling point to go up. So because whenever you are dealing with heavier petroleum fraction like reduced crude oil, so I have told you while talking about vacuum distillation unit, so the normal distillation, if I want to distill spindle oil, like heavy intermediate oil, in normal atmospheric pressure, so it has to be distilled approximately 500 to 600 degrees centigrade. So at that temperature, if you heat it up, so your crude oil or whatever products that you are handling, your reduced crude oil is going to thermally degrade. So in order to prevent that, we have to lower down the pressure so that my boiling point also goes up. So if there is some certain leakage that might have taken place, so that's why your vacuum, so there is a slight drop in the vacuum causes boiling point to go up, leading to low vapor flow, loss in production, and off-spec products. Off-spec means like yours, as per the specification, you won't be able to produce your petroleum fractions in vacuum distillation column. And last but not the least, this is also a very important factor, which is the wet feed. Like if a column is typically fed with dry hydrocarbon, but the feed becomes contaminated with water, then at some point when water and hydrocarbon mixture enters the tower, the water can vaporize so rapidly that it causes overpressure event. That I have told you, like because of the overpressure, even internals like internal trays and packing can get damaged severely. So this will damage the trays. This effect can detrimentally affect the column efficiency as well as the product quality. So okay, so the boiler temperature is done. Okay, now comes to the another factor, which is the column diameter. So column diameter, the most of the above factors that affect the column operation due to vapor flow condition, either excessive or too low, the vapor flow velocity is dependent on the column diameter. So like weeping determines the minimum vapor flow required, while flooding determines the maximum vapor flow that is allowed. So like you have to understand that the information on weeping will tell you that much amount of vapor flow has to be there within your distillation column, or else like top tray product is going to mix with the bottom tray product because of weeping. And the flooding information would be able to tell you that okay, so like if the vapor flow within my system, if it goes beyond this, so what will happen, one tray liquid will get mixed up with the another tray liquid, then also my separation efficiency, product quality is going to go down. So it actually tells us about the maximum vapor flow that is allowed. Hence the column capacity. If the column diameter is not sized properly, the column will not perform well. Not only the operational problems will occur, the desired separation duties may not also be achieved. So like deciding on the whether to go for a higher column radius or for a low column radius, depending on the composition, operating temperature, as well as on the vapor flow within the system, you have to come up with a conclusion how you have to deal with this column diameter. So that also plays a role. So other than that, this condition we have already talked about. If you are operating with crude oil that is having too much of suspended solid, so that solid is definitely going to deposit on the trays and packing. So remember that the actual number of trays required for a particular separation is determined by the efficiency of the plate, and packing, if the packing is used, does any factor that cause decrease in the tray efficiency will cause performance of the column to change. The tray efficiency are affected by fouling, where like after too much of use, because there is going to be some wear and tear on the tray item. Corrosion can also take place if you are not properly removing your salt from the crude oil, so that is also a factor. Then comes the rate at which it occurs depends on the properties of the liquid that are being processed. So that also is a factor, because the rate at which the corrosion is happening or the fouling is happening or wear and tear is happening, that is also going to determine how my distillation column is performing. So based on the compositional quality, whether your salt crude oil is having higher salt, then you have to choose your what should I call it, choose your tray construction material for your tray should be specific so that it can resist your corrosion effect. But obviously suspended solid before it enters into your distillation column should obviously be like removed, or else like even if you use some anti-corrosive trays inside your distillation column, because of the fouling, your performance of your distillation column is going to go down. So like you see, so many factors actually comes together and like determines your performance of your distillation column. But last but not the least is the weather factor. So how weather affects, so most distillation columns are open to the atmosphere. Here they are talking about atmospheric distillation unit. Although many of the columns are insulated, changing in temperature like weather condition can still affect the column operation. Thus reboiler must be appropriately sized to ensure that enough vapor can be generated during cold and windy spells, and it can also be turned down sufficiently during hot seasons. The same applies to the condenser also. For example, if you establish a let's say refinery in desert conditions, so in desert, in during the morning time or during the daytime, the temperature comes close to 50 degrees centigrade, and during night time it goes down as 3 to 4 degrees centigrade. So like there is a huge fluctuation in the temperature. If your deboiler as well as your condenser is not designed properly to handle those like change in the climatic condition, change in the temperature, change in let's say moisture content, so this is going to cause a significant amount of problem in the operation of your distillation column. So like weather condition, reboiler temperature, reduction in vacuum pressure, whether water is present or not, what is going to be my column diameter, fouling, corrosion on the trays and packing, then adverse flow conditions like weeping, dumping, entrainment, foaming, flooding. Other than that, this reflux condition, feed condition, all of these factors comes together and can affect your performance of your distillation column. So like whenever if I ask factors that may affect the performance of my distillation column, I think that you people should be able to answer it. And what do I mean by flooding, what do I mean by entrainment, those details have also been given there, and under what condition flooding can happen, this weeping can happen, that has also been discussed here. Maybe only the puking part is not mentioned here. So like if the vapor flow condition even goes beyond the flooding, then only puking happens. So like at least this distillation column, most of the things are completed. Now coming to the last but not the least, use of the petroleum products. Since we have been finally being able to come up with the main products, like from distillation columns only, all the main products you are already going to produce. But after this distillation column, since we want more and more light distillate like LPG or gasoline, or middle distillate like your diesel, so that's why you have to further process it in units like cracking, reforming units. So that we'll be discussing later. But since distillation column itself produces a wide range of products, and like in what are the condition for what application this type of products are actually used, so we will be discussing in this particular slide. So so I have worked, not work, actually I have done an internship in this ICL Haldia refinery. So in ICL Haldia refinery basically deals with Middle Eastern crude, and since Middle Eastern crude actually I would suggest is having a higher sulfur content. So crude that is having higher sulfur content, you can actually use it to make lubricating oil. So ICL Haldia refinery actually specializes in making lubricating oils also, which is actually nothing but this heavy vacuum gas oil, light vacuum gas oil. So so lubricating oil production is also one of the valuable petrochemical products that your refinery produces. Other than that, top part is LPG, which is nothing but the combination of butane and propane, a portable fuel for production and consumption for both domestic and industrial application. Motor spirit, it is primarily used as a fuel in internal sorry, in internal combustion engine. Mineral turpentine oil, so MTO is actually, you can actually utilize it as a extraction solvent for cleaning purpose, degreasing purpose, or as a aerosol or paint or wood preservative, you can utilize it. Superior kerosene oil, so kerosene for like anti-rust, as an insecticide or pesticide, you can use it. As a solvent in paint and varnish formulation, you can utilize it. So other than that, for home, like small heater also, kerosene can be used as a fuel. Aviation turbine fuel, this is the main fuel for your aircraft engines. Can anybody tell me what is the fundamental difference between SKO and ATF? SKO and ATF. Like as a if I want to use consider a fuel to be used for aircraft for in a aircraft engine, what property? What?
Pour point, sir.
Pour point, yes, pour point, because at a very low temperature, if I want to run my engine, I have to focus on the pour point itself. If my pour point is like not low enough, then at that very high altitude, the outside temperature is -40, -50 degrees centigrade. So at that temperature, if my turbine actually like oil freezes out, so you can consider the devastation it can cause. The definite the plane is going to crash. So, and there is this the second one, that is this Russian turbine fuel. So because in earlier times in Indian military, we definitely we actually depend on too much on Russian based aircraft, for example MiG, Sukhoi. So those type of engine actually only would be operate in this Russian turbine fuel. For that, your freezing point has to be much below than -50 degrees centigrade. So that is a very specification. So this type of RTF also was produced in Haldia refinery. And then comes this high speed diesel in compression ignition engine. We actually use diesel for locomotives, pumps, stationary diesel engine also it can be used. Jute batching oil, like for example for jute bag creation, you have to use this like jute batching oil to make your jute fiber flexible, because after initial processing your jute fiber remains as very stiff. To make it more malleable, or let's say to make it more flexible, this jute batching oil is used. Naphtha, it is basically used as a feedstock in petrochemical plants. Other than that, it can also be used as a solvent in paint, as well as if you want you can use it as a fuel also. Furnace oil, it is primarily used in steam boilers in power plants, like ships, as in industrial plant. In commercial fuel usually are blended with petroleum fraction to reduce its viscosity and flash point. So but because it's actually contains higher heavier petroleum fraction, like carbon range is also higher, the carbon number is also higher, so actually it has a higher viscosity. So to reduce its viscosity, it has to be either mixed with some other petroleum fraction, or so by mixing those fraction we actually lowered down the flash point for this furnace oil. The last but not the least comes this lube oil production. So lube oil, actually we produce it in this vacuum distillation unit, this light vacuum gas oil, heavy vacuum gas oil. So let me just further move forward. Okay. Okay, so then after producing this light vacuum gas oil, heavy vacuum gas oil, you can actually add some amount of hydrogen there to convert into light and middle distillate, and it can also be processed as a lube oil production. It has to go through some a little bit more purification, and then it can be directly used as a lubricating oil. But if you don't want to use it as a lubricating oil, because obviously if you sell it as a lubricating oil and compared to if you sell it as middle and light distillate, the cost return is going to be more. So that's why this light vacuum gas oil, by adding hydrogen, you convert it into light and middle distillate, as well as it can produce propane and butane also. And then this products you can further utilize it. And heavy vacuum gas oil, after doing some amount of solvent extraction, because some wax can also be present there, so this wax you can directly use it in like cosmetic industry to make different products. Then you come to this lube oil base stock, and then after adding some additives you come to final lubricating oil. So solvent extraction and dewaxing process your heavy vacuum gas oil needs to go through till it comes to this like lube oil grade, and some amount of additives also needs to be added there. So based on its carbon number range, like hydrocarbon range, basically the carbon number only has been given here, as well as the petroleum fraction. And please turn off your microphone. Hello. Yeah, who's this? Yeah, who's this? I'm asking you to turn off your microphones. Okay, so you see, these are the different types of petroleum fraction we actually get from my after doing this distillation process, and these are corresponding boiling point range, and this is the carbon number for corresponding to different petroleum fraction. This has been listed out here. And then this part is actually talks about the use. Like here I have specifically focused on a particular IOCL Indian Oil refinery and what are the products it produces. So this also pretty much talks about in which particular domains you actually utilize petroleum products. So transportation, obviously you use diesel, you use gasoline there, as well as in aviation turbine fuel, it is also you use it in transportation purpose only. Power generation, but sorry, in India we don't use like oil for power generation. We don't have too much of oil. So mostly in Middle Eastern countries where they have abundance of oil, they have the luxury to use it for power generation purpose. But maybe if you, like for example, let's say you have a power cut in your locality, now you have a generator. So then in emergency condition you can use diesel to run those what should I call it, electric generator, temporary electric generator. But for actual purpose, actual power generation, other than Middle Eastern countries, no countries actually uses like petroleum based products. Other than this, lubricants, I have already told you, it actually, like you have to further process heavy vacuum gas oil, like you have to do solvent extraction and dewaxing, then we'll come up with this like lubricating oils. Other than pharmaceutical industry, so this actually pharmaceutical agriculture industry, these are actually you have to further process it in petrochemical plants, and then you will come up with this type of chemicals which can be utilized in pharmaceutical industry, agriculture industry. Other than that, as rubber, synthetic polymer, polyethylene, polypropylene. So those things are like you have to these things actually you have to further process it in petrochemical plants, and then only you should be able to get it. And finally, last but not the least, detergents, mostly it comes from your distillation after processing it in petro chemical plants only you will have it. Wax, you can get it from this process where after you have taken out the paraffinic wax, so that you can actually add it into any cosmetic product, so that wax you can use. So Vaseline is nothing but a petroleum jelly, so which is also derived from petroleum products also. And kerosene, you can use it as a solvent, you can use it for rust removal, insecticide removal, but also as a like for lighting up, like in rural area in India still kerosene is used as a source of energy, like for lighting up lamps. And then in other countries, for cooking, kerosene is used lighting, and for other domestic purposes like rust removal, solvent for paints, insecticide, pesticide, you can utilize it. So this is all about this entire applications, different types of application of petroleum products. I have also talked about for a particular petroleum refinery in India, what are the products that they produces, and from that products, what are the uses of those products. Those things also I have explained here. So at least this module number 2 is now complete for all of us. Now only things that remains, I have to give you some problems on this. So for that purpose, I'll just see that whether tomorrow I can do it or not, or in the next week definitely I am going to give you some problem on this. I'll also solve some of the problems here and give you some problems for your home task. You do it at your own convenience. And next class either I can do this math problems or I can start the module number 3, which is the cracking. So there I'll be talking about steam cracking, hydro cracking, thermal cracking, and fluidized catalytic cracking. So with this, I conclude today's class. I think I have covered a lot of topics here, and I'll also share the PPT so that you can also go through the PPT for you at your own convenience. Okay, then that would be all for today. Go and answer the poll question for getting attendance. Thank you all for attending today's class.
Thank you, sir.
Sir, for last class, when you told us that you will give the poll a little late, sir, like I
I
had a class, so I just forgot about the poll because,
think I have
sir,
already given you attendance or what? Have you checked it?
sir, can you please come again?
I have already given you attendance. You messaged me. So I had
Yeah,
already
yeah.
given you the attendance, I guess,
Okay,
for
okay.
that
Thank you,
class.
sir. Thank you, thank you.
Okay, okay.
Oh,
Okay,
what
thank
happened,
you all.
sir? Hello, sir.
Thank you, sir.
Yeah, yeah. Yeah, okay. Yeah, tell me.
Sir, I was asking about our marks, the quiz marks.
Yeah, quiz marks I have actually uploaded for 18 students. The remaining student I'll upload it today. Because of I was busy with some other tasks, I could not complete it. So today itself I'll upload the remaining. So don't
All
worry.
right,
By
sir.
tonight you will get all the marks.
Okay, sir. Thank you, sir.
Okay,
Yes,
okay.
thank you.
Thank you.
Sir, sir,
Yeah, yeah.
sir, it's taking me some time to vote in the poll, sir. I will vote in next 2-3 minutes, sir. Can you consider, sir?
Yeah, okay, okay. I will. Okay, thank you. You can leave.
Thank you, sir.